Okay, welcome back. This morning we're going to continue our study of the Pythagorean theorem, and we're going to connect that concept with the distance formula. You should have your class notes and your calculator and your pencil all ready to go, and I'm going to start working right here on the distance formula. If you're not ready, pause, get the things you need. I'm going to try and, let's see here. I'm going to try and do this a little different. Let's see if I can. Alright, I think that'll work for us. Okay. In front of us here, like I said, we're connecting the distance formula, which helps us find the distance between 2 points if we know the coordinates. We're going to connect that with the Pythagorean theorem, which states that a squared plus b squared equals c squared. Okay, the sum of the square of the legs is equal to the square of the hypotenuse. The hypotenuse is c to long side. So on this triangle over here on the right, all right, we've got this right angle here. And so we know this is a right triangle, and we know that the side opposite of that, all the way on the other side, that's going to be called c, or the hypotenuse, right? And we know that these other two sides are called A and B. They're called the legs. So I've labeled those. I've also figured out how many units long they are. So this one on this side is 1, 2, 3, 4 units long. And on the other side it's 1, 2, 3, 4, 5 units long. And the Pythagorean theorem, like we said, tells us a squared plus b squared equals c squared. So 4 squared plus 5 squared should equal the length of this line right here, c squared. So we're going to do 16 plus 25 equals c squared, and that's 41 is equal to c squared. And if we take the square root of both sides there, right, you guys can use your calculators for all this stuff. You know how they work. Okay, 4 to the second power plus 5 to the second power equals, and then take the square root of 41, and that equals 6.403, so approximately 6.4. So the length of this side right here is about 6.4. Now the distance formula, which we're about to connect, and we're gonna get to on the next page, right? Distance between the points is, you guys remember how we label these points? We could label this point x1 and x. Oh, I'm sorry, not x. It's x and y. x1 and y1. My mistake, I apologize. And then this point over here would be x2 and y2. x2 and y2. Okay, the distance formula tells us that if we find the difference between y sub 2 and y sub 1, wow. Oh boy, I'm all sorts of confused here tonight. What's going on here? Okay, y sub 2 minus y sub 1. And then I square that value and add the difference between x sub 2 and x sub 1 and square that. That's going to give me the distance. And it's basically doing the same thing we did here with the Pythagorean theorem. We're gonna connect all this stuff here. So I'm gonna go to the next page. I'm going to flip right over here. You guys are following along with me. It says proving the distance formula. Okay, and you know, here it's x2 minus x1 plus y2 minus y1. That's the same thing we just wrote on the other side. Okay, it's not going to make any difference either way. We're combining these two values. Okay, so we've got these points on a coordinate plane. We've gone back to a coordinate plane, and your paper just has P, Q, and R, and they're labeled x1, y1, x2, y2, and then this is x2 and y1, because to make a right triangle, the x value here is going to have to be the same as this x value, the distance from the y-axis, and the y value here is going to have to be the same as the y value here, right? The distance from the x-axis, for this to be a right triangle, for this to work out that way. So now what we can do, right, I'm trying to find, let's say I'm trying to find the distance between points P and Q, right? Well, if I have points P and Q and I know they're at 3, 2, 1, 2, 3, and then 1, 2, 3, 2, and I have point Q, which is at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, so 6, 6. Well, I can use the distance formula to find the length of that line. Okay, so again, we're going to say D is equal to the square root, right? My x sub 2 is 6, of 6 minus x sub 1 is 3. And then I'm going to square that value, and I'm going to add the difference between y sub 2, which is 6, and y sub 1, which is 2, and then I'm going to square that value. And then I'm just going to take this one step at a time, right? 6 minus 3 is 3, so 3 squared, plus 6 minus 2 is 4, so 4 squared. So that's going to be D is equal to the square root of 9 plus 16. And, don't be afraid to take these things out and use them. 3 to the second power plus 4 to the second power equals 25. And then we're going to find the square root of 25. That's a perfect square. We know that's 5. 5 times 5 is 25, right? So D equals the square root of 25. And so D equals 5. Now, I can also use the Pythagorean theorem here. I put this point out here and called it R, right? And what we do, right, we're basically just counting the number of units to the right from point P. It's 1, 2, 3, right? So that's one leg, and then up 1, 2, 3, 4. Okay, so if this is C, if this is my hypotenuse, it's opposite of that right angle that I just made, then this is A, and this is B. Okay, so again, we can use that Pythagorean theorem if we have these points on a coordinate plane, and this is kind of how we prove this, right? So A squared plus B squared equals C squared. Well, A is 3, and B is 4, and we don't know what C is. Well, if we take the square root of this, and we take the square root of this, well, then we have the square, well, this looks very much like this, except now C squared is in there instead of D. The distance between these 2 points is the same thing as the hypotenuse of the right triangle that we make on the coordinate plane. Okay, so that's kind of how we prove the distance formula. I'm gonna move on to the next page, right? Because this is the same thing. Square root of 25 is equal to square root of C squared, and so 5 is equal to C. So the distance between those 2 points is 5. Okay, so on the next page, basically, we don't have the coordinate plane with us anymore. Okay, so we're going to find the distance between these points just by using the distance formula. Okay, and the distance formula again, right over here, D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, we're trying to find the distance between the x values for one leg and the distance between the y values for the other leg. Okay, and then the distance between the 2 points is the hypotenuse. So we're going to plug in these values. I labeled them x1 and y1. X comes first, y second, and x2, y2. And then I plug all those values into this equation right over here. Right? And I have negative 5 minus 6 squared plus 5 minus 2. squared. Okay, and so that's negative 11 squared. And negative 11 times negative 11 is 121. So if I do negative 11 to the second power, that equals 121. Okay, and if I do 5 minus 3, that's 3, and if I square that, that's 9. And so what I wind up with is the square root of 130 is equal to the distance between these 2 points. And the square root of 130, second square root 130 equals, it's 11.40. Okay, and we rounded that answer to the nearest tenth right there at 11.4. Okay, there's another example right next to that. We're just going to keep moving right along. And I've worked these out already. I'm just going to kind of talk you through them as we go. I'm going to clear this out. So I've got 2 points, right? These are 2 points on a coordinate plane, and I'm trying to find the distance between these 2 points. This ordered pair is 1 point, and this ordered pair is another point. Okay, and the distance between my x values is 14, right? If I do 7 minus negative 7, I get 14 squared. And the difference between my y values, if I do 7 minus 1, the difference there is 6. And if I square that, it's 136. Okay, so then when I add those two together, I get the square root of 232. And that is approximately 15.2 if we round to the nearest tenth. That 3 tells us to stay right at 2, and that's where we're going to leave that. And this just means approximately right here. Okay, you can just, if you want to say you round to the nearest tenth, that's fine. Okay, we're going to move on and do a few more together. Alright, so here again, we're going to use the distance formula, right? So I've labeled my points x1, y1, x2, y2. It just kind of keeps my thoughts organized, and then I plug all these values into this equation right here. So first I take x sub 2, which is 6, and I plug that in, and then I subtract x sub 1, which is negative 4. And when I subtract a negative, I'm actually adding, so that's 10 squared. And then the difference between my y values, I start with my y sub 2, it's negative 6, and I subtract negative 7. Okay, and if I subtract negative 7, I'm actually adding 7. So that's positive 1 squared, and 1 times 1 is 1. So what I'm looking at, the length of the line that connects these 2 points right here is equal to the square root of 101, which is approximately 10.05. Check it out for yourself. The square root of 101 is equal to 10.04, 10.049. Okay, so we rounded that one to the nearest hundredths place, the hundredths place on that one. Now we're going to look at another example right next to it. But before we do that, you can see over here I wrote that the difference in x values is 10. The difference in y values is 1. Okay, 10 squared plus 1 squared is equal to 101. So, you know, by the Pythagorean theorem, a squared plus b squared equals c squared. So to find c, all I have to do is take the square root of that right there. And that's connecting the distance formula and the Pythagorean theorem, how these all work together. Alright, and so here we've got another example. We've got 2 points. These are points on the coordinate plane. We can connect those points, and that would be a line segment in between them. And we label those points, right? This ordered pair is 1 point. This one's another one. This is not new. Okay, the distance between those points is equal to the square root of x2 minus x1. So 0 minus negative 3 is 3 squared. And then we're adding to that 3 minus negative 6. And then we square that. So we have 3 squared plus 9 squared, which is 9 plus 81. And we're still going to find the square root of this whole thing. Nothing, we're not changing any of that as we go until we perform the operations. So we're looking for the square root of 90, and that will be the distance between these 2 points, or the length of that line segment. And again, if we put these on the coordinate plane, we could just create a right triangle and use the Pythagorean theorem to do that. Okay, D is approximately 9.49. You guys have your tools. So the square root of 90 is equal to 9.486 or 9.49. And then if I square that value, if I square that value, I get right back to 90. Okay, those are inverse operations, just remember that. So now we're going to look at an example on the coordinate plane. Okay, on the coordinate plane, we can do the same thing. So in this example, I have a line segment in between these 2 points, okay, and I've labeled them A and B. And A is at x is 2 and y is 4. So those are my coordinates of point A. And then B is at x equals 5, right? 5 units to the right and 5 units up. So it's at 5, 5. Now I can use the distance formula to find the length of that line segment, or I can come across and come up, which creates a right triangle, right? The right angle's right here. So then 1, 2, 3 units, I'm going to say that one of my legs is 3 units long, and then 1 unit up, so I'm going to say my other leg, B, is equal to 1. And I'm trying to find the length of this line right here. Okay, so what I did was I took A, and I squared it, and I took B, and I squared it, and that should equal this right here, the distance, or C. Right, A squared plus B squared equals C squared. Okay, it's called D squared here because we're working with the distance formula. We're just trying to connect these concepts. Pardon me. So if 10 is equal to D squared or C squared, then the square root of 10 is equal to D. Right, if I take the square root of both sides, then I get to D equals the square root of 10. And the square root of 10 is approximately 3.162, 27766. Okay, so that would be the length of that line segment. And you can find it the other way as well, right? We can do D equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And we labeled these points up here, right? So x sub 2 is 5 and x sub 1 is 2. And I would square that, and I would add y sub 2, 5, minus y sub 1, 4, and I would square that. And you're probably starting to see that this is going to look pretty similar to some of this up here. So I have 3 squared plus 1 squared, where the square root of that is equal to D. Okay, that looks very much like this. The only difference is there's a square root sign here, and there's no exponent of 2 there, right? Those inverse operations. So there we are, we're at D equals the square root of 10, which is the same thing we had up top. Okay, we're going to keep going. We're going to finish this up. I've got one more example here where we can look at the distance formula and the Pythagorean theorem. Okay, these points are on a coordinate plane. We know what the coordinates of these 2 points are. So I can make a right triangle, right? I go over 1, 2, 3, right? It's just a slope triangle. You guys remember finding slope? So the slope of this line, right, the rise over the run, is 6 over 3. But we're going to go 1, 2, 3 over, and 1, 2, 3, 4, 5, 6 up. So my right angle is here. So this is my hypotenuse, and this is 6 is equal to side B, and 3 is equal to side A. Doesn't matter which one I call A or B. There's my slope triangle. It also gives me the legs of my right triangle. Okay, so 3 squared plus 6 squared, 3 plus 6, and square those should be equal to the square of the hypotenuse. So 9 plus 36 equals c squared. So 45 equals c squared, and the square root of 45 is equal to c, and that means that c is approximately 6.71. Well, now down here on the bottom, what we did is we used the distance formula for the same purpose, right? We labeled this point as -1, -4. -1, back 1, left 1, down 4. Okay, the other point is 2 to the right and 2 up from the origin. And so I plugged those values into my distance formula, which is right up here. X sub 2 minus x sub 1 plus y sub 2 minus y sub 1. Square both of those differences. So you get 2 minus -1 squared plus 2 minus -4 squared. So the distance between these points again is equal to the square root of 3 squared plus 6 squared. It's starting to look like what we did up here. And so the distance is equal to the square root of 9 plus 36. The distance is equal to the square root of 45. We already found that that is approximately 6.71. And I don't think we did. Let's just double check. Square root of 45 is 6.708. And that'll work. Okay, now we're going to take this and we're going to apply it to a little bit of independent practice. You guys are going to work on your own for a little while. I'll put another video up if you still want more help.